So my next guests today are Ryan Banfield and Mike Slowick, okay, from a company called Extrude to fill. Okay, so gentlemen, welcome to the show. I believe that you've come out with a new process for basically doing plastic or thermally conductive extrusions for batteries and different applications. Maybe you can start by explaining to me how your technology works.
Sure, no problem. Thank you. Yeah, the company is called Extrude to Fill, X2F for short. We're focused on, we've developed the technology and equipment for protecting PCBs and electronics in a unique way with thermally conductive materials. Right. A lot of companies would generally say that these materials we're using are quote unquote impossible to mold. And that's really the innovation, is being able to process these homogenously and get them to protect a PCB and electronic that may traditionally be conformally coated or potted. What we're doing that's different is we're able to provide enhanced heat management and conductivity to these PCB and electronics. We're doing that with highly filled materials. These highly filled materials, normally they're very difficult to flow over PCB and electronics, and that's what's really unique. With our system, we're able to process these highly filled materials very easily and impart better heat management across a wide range of industrial, consumer electronics, medical, different applications in different industries.
Right, okay. So I think it's important to note that you don't actually make the materials, you make the system, you make the equipment to be able to create this encapsulation of these materials.
That's absolutely right. We use materials that are either on the market today, or we partner with material companies, and they'll come up with new formulations for our technology. So we do have several partnerships in place with material providers in different classes of materials. So we do a lot with LED heat sinks, with thermally conductive polycarbonates, where we can make the heat sink and the LED all in one mold. And generally, these are very difficult. They can be very difficult materials to process, right. And we're able to readily process those with our system.
Okay, I think we've actually got a photograph of the machine itself. Maybe we can take a quick look at that. And Ryan, you could perhaps talk us through how this system works.
Yeah, sure. So what we're looking at here is the rotary table adaptation of our E30V production equipment. This is our high volume unit here for extruding these thermally conductive materials. Operates by having a rotating table that can accommodate up to 8 molds on it. In the 12 o'clock position there, you can see that the mold is being extruded into with the vertical hydraulic piston on the top applying pressure, and then once the part is finished extruding, it rotates into the next position. The next mold comes in, allowing us to continually mold on demand as the parts are rotating through their cooling cycle.
So what are these heads, the 3 heads at the top there of that?
So that's our laser system for safety. Basically incorporates allowing operators to operate the machine without sticking their arm in while something's rotating around. That's to show the safety curtain around our equipment.
Right, okay. Okay, that's fine. So you've got a couple of samples here that we can look at. Can you show us some of the samples you've got here on the table with the moldings?
Yeah, absolutely. So here we've got an example of a heat sink with an LED module that's incorporated into it. What makes this interesting is there is no thermal interface material here or no attachment hardware. This is also a thermally conductive plastic, so it's 50% lighter and extremely close to the same thermal performance you'd expect with its aluminum counterpart. It also brings, a lot of various other savings in terms of not having that attachment hardware, not having that thermal interface material. It's fewer SKUs that you have to keep in inventory. It's a faster production cycle, and it's much easier to implement.
Right. And what about the pressure? I mean, obviously it's a plastic injection molding system you're using, but you're not applying a lot of pressure that might damage the electronics. Is that correct?
That's absolutely right. Generally, we see our system can operate about 70 to 90% lower pressure than traditional injection molding. So you wouldn't be able to mold over these electronics or the LED with traditional systems because the high pressures would break the sensitive electronics or the LED, and that's one of the areas we excel. We can do it all in one step with keeping the integrity of the LED or electronics intact.
Mm-hmm. Okay. And what about making the molds? How easy is that, and how long does it take?
Yeah, sure. Because we operate at significantly lower pressures, we have a lot more flexibility in the materials we use to make these molds. They don't all have to be steel molds. In a lot of cases, we're doing production tooling with aluminum molds. Those can be made quicker, they're cheaper. And we're doing a lot of our prototyping with 3D printed molds from low-cost systems. Generally, these materials that are difficult to flow, that are highly filled, you wouldn't be able to use 3D printed molds at all. And we're able to quickly, in the same day in a lot of cases, print a 3D mold and prototype parts for customers. And that's a huge advantage for us over some of the other technologies out there.
Right, right. So are you doing, are you selling these machines on their own, or are you doing this also as a service for customers?
Yeah, so we're providing a technology for our customers and providing performance benefits. We're based in Loveland, Colorado. We do manufacturing for customers of high performance components, and we'll also provide machines and the technology to our customers, either CMs or the brand owners, after we've piloted it. Almost all the time we do the prototyping and piloting at our facility before transferring that to a customer's site for full production.
Right, right, that makes sense, yeah. Great. So it sounds like, how long have you been going? How long has the company been?
So the company's been around for about 5 years, but the co-founder and CTO, he's been developing this for over a decade. The co-founding CTO, his name's Rick Fitzpatrick. He comes from the traditional injection molding industry. He worked at Flex for many years. His inspiration for this was traditional injection molding machines. They can be the size of a conference room. They can be really, really large, moving small amounts of plastic in some cases, 1 or 2 grams. Yeah. And he said, look, there's got to be a better way. And so he started this company in his garage, developed the technology, machined all the components, developed the algorithms, and the job of Ryan and I is to commercialize it, get it in the hands of the customers in these applications that are highly differentiated and provide extreme performance benefits to the customers.
Well, it's certainly a very unique technology, gentlemen, and it's been very interesting to see it, and I want to thank you for coming in and telling us about it today.
Absolutely. Thank you very much for the opportunity.
Thanks for having us on.
Thank you.